Alrighty, everybody. So what we have here tonight is an introduction to Manual D for duct size calculation using um, Wrightsoft's Wright Suite. Okay, so we've got here a single family residence. It's got a bunch of rooms. Okay, maybe some of these are bedrooms, living room, kitchen, bathroom, etc. Okay, it's really irrelevant for what this is. We know that the properties have been set in terms of the properties for the walls, the windows, the ceiling, the floor, etc. We've got windows and doors and sliding glass doors, etc. All right, up here at the top, we've got a various toolbars. Right now, we are in the manual D, the right J or manual J toolbar. If we head over here to the worksheet, okay, we can see that the entire house is a little over 1,700 square feet for the entire house. Okay, and then we've got the loads here, total load on the house, etc. And if we wanted to see the total room load for each room, so this is room one. We see here for heat, this is what it is right here, and this is what it is for cooling. And then if we go to room two, we would see it's 5,289 and 1,621 for cooling. All right. So now we're going to go to we're going to head over to the manual D, which is the duct sizing calculation. Before I head over there, a Google search for ACA manual D pulls this up, manual D residential duct design. Okay, so this is the industry standard here in the United States for residential duct systems. Okay, and it's used to calculate the size of the ducts that will carry the airflow. Okay, and then it also has, of course, other things as well. But crucially, there's duct size and calculations, air distribution, etc. Okay, um, it's got all kinds of tables and equations. There's system efficiency things to consider. There's also it also deals with the equivalent lengths due to fittings. So if you have so in any air conditioning system, you're going to have things like fittings and elbows and joints and so on and so forth. And all of these cause a pressure loss. And in Manual D, these pressure losses are presented as additional equivalent length of duct. All right, so back over here. So the first thing we need to do is within the Wrightsoft software, we need to head over here to this tool where it says blower, and we are going to place it. Now, we can place it wherever and sort of play around with everything. Okay, meaning we can remove it. We can move it and relocate it. Let's do. Hold on. Let me try putting it here like this. Um, let's see. You know what? Okay, hold on. How about this? So I see that there's a supply in every room. This is a large room, however, it is interior. So it's possible that one supply grill, which is the supply outlet, could be sufficient. It's funny that that one has two, of all things, go figure. Okay. All right, let's try this layout. Let's see if this is good enough. Now I'm going to go for a radial layout. So there's something called a radial layout or a radial duct design. Okay, and it looks like this. Think of like a wheel, a bicycle wheel, right? So you've got the hub, the axle at the center, and everything extends from there. Okay, or think of it as sort of like a spider web. Okay, so here you see you've got the main system is sort of in the center, so to say, and then the branches extend outward from the center. Another system might look, let's say, let's say like this, okay? Where, you know, it could branch off in either one or two directions. And then, you know, these are called trunks. And then you'll have, excuse me, you'll have other ducts uh, break off from the main, from these main trunks, okay? And then they will go deliver the air, the cooled or the heated air, to each individual room. So I'll start with a radial system here. Um, well, let's play around with it and let's see what it looks like. So knowing that it's a radial system, I am kind of sort of trying to space things in such a way that, first of all, that they don't collide with each other. Okay, that's going to get in the way of that. What if we did it like that? That should be okay. All right, let's see. So let's click on this box here, and then right-click under the tab for General. Right over here for duct layout, says user defined. Let's select radial. Okay, and let's see what happens. Let's see what kind of shape it gives us. Okay, okay, not bad, not bad, not terrible. Now, not always, but very often in a radial system, um, not always, but often, these kinds of ducts will be what's called flexible ducts. These flexible ducts, they look something like this, right? They're usually insulated, and you know, you can kind of snake them through. Um, they can be convenient to use, and you know, to position them. They're easy to work with, but they definitely have some disadvantages, which is that if not installed properly, then they can develop kinks, which will, of course, cause pressure losses and disturb the flow of the air. All right, so that's what a radial system looks like. What is let's change it. Let's set it to let's go to a one level trunk. Okay, that looks a lot more like what we saw here, right? And this might be you know, you may be familiar or may have seen like those sheet metal type of systems, and that's kind of what this is. Yeah, let's move that around. Okay, this is too close, so we're gonna have to move. So what I'm doing now is I'm moving these registers. You can call them a grill, a register, an outlet, kind of, it's all the same. Moving that, okay, that's a little better. This doesn't have to be so, that could be like that. All right, that's fine. This room, okay. Hold on a minute, I'm just kind of moving things around so visually they look a little bit more appealing to me. Oh my gosh, what's going on? There we go. All right, sorry for that, folks. Okay. Now, so you'll notice we've got two different kinds of lines. We've got these thick blue lines and we've got the dash line. So the thick blue lines are the supply. That's the supply air, meaning that's the air coming out of the vents that you feel as cool air in the summertime or warm air in the wintertime. These dash lines here, this represents the return, right? So the system, the HVAC system is constantly recirculating the air. It's not always pulling in air from outside. It would have to work too hard. Instead, it sucks in the air that's already inside the house, sends that back to the coil system to cool it down or heat it up, depending on, you know, what you're running, cooling or heating, and then it sends that back out through the supply ducts back throughout the house. Okay, I'm gonna put in another return grill because if you think about it, so if I click on it, you'll see it highlight. If I click on this one, it highlights all of these supply. when I select this one return grill, it highlights all of these supply grills. What that means is that all of the air coming out of these supply grills has to equal the air coming into this return grill, which means, if you think about it, that let's see, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 supply grills and one return grill, right? Just from your experience, you know that these supply grills, they're usually not that big. They're rectangles. You'll see them on a wall. They're usually, I don't know, let's say 10 inches long by 4 inches high, something like that. Maybe 12 by 6, let's say. So this is going to have to be really large in order for the amount of airflow coming out of all of these to be equal the same as the airflow coming into this. So this return grill is going to have to be really large. It's kind of inconvenient sometimes to have one really large grill. So let's install another one. Let's place another one, and we can put it kind of anywhere we like. There we go. So now let's see what happens when I select this return grill. So you see it highlights these ones. And so what that tells me is that the air coming out of these, so 1, 2, 3, 4, 5, and 6, these supply grills will equal the air coming into this one return grill. And then if I select this one, then only these ones are highlighted, right? And not these ones, okay? We will get into the details more, but so the reason why that's important was so for a number of reasons. So like I said, number one, it means the return grill is going to have to be really large. That could be a little challenging to work with. And the duct for it will have to be large. But also, there are limits on the speed of the air inside the ducts, okay? So for these ducts here, for the supply line, okay, the limit is 900 feet per second. That's the speed of the air moving inside these ducts. For return air, okay, that's the air inside of these dashed lines. The limit is 700 feet per second, which means that we will require larger ducts to slow down the air. If you've got two ducts that are different sizes and you have the same pressure pushing the air, the larger duct will have slower air and the smaller duct will have faster air. So there's a limit on how fast the air is allowed to move through these ducts. All right. For now, let's just keep. We haven't labeled any of these rooms as to which one is a kitchen or a bathroom or any of that. The type of room does restrict where the return can go. You cannot return air from the bathroom. And offhand, I think you cannot return air from the kitchen as well. I could be wrong. Anyway. All right, so let's see what, this is what we got. This is the layout that we have for now. And let's click up here by the toolbar where it says equipment. Let's hit that button. Now, for this particular project, we will select this one here that says Package Air Source HP. HP means heat pump. Okay? A heat pump is a system, and don't think it provides only heat. A heat pump can provide both heating and cooling. Okay? I'm not going to get into it in this video. Perhaps I'll do one in the future with sort of like a more detailed review of how an air conditioning or heating system works. But basically, there's a working fluid called a refrigerant. And basically, it gets compressed, which means squished, okay? And when it gets compressed, it gets hot. Now, if we want hot, meaning if it's winter outside, then we want that increase in temperature in the working fluid. And in the summertime, we want the cold. So what we do is we compress it, it gets hot, and we reject it by blowing a fan over it outside to the outdoors. You may be familiar with having walked by an air conditioning system that's outside a home, okay? And next time, pay attention that if the air conditioning system is running in the summertime, there should be warm to hot air coming out from that system, because we are rejecting that to the outside and we are keeping the cold on the inside. Okay, so we compress it to get the heat, and then we expand it to get the cold, and that's basically what we're doing. We're cycling it inside the system. So this system that we are about to pick is capable of both heat and cold. Okay, now let's go select our actual system. So what's great about this software is that it automatically does the manual S, which is the selection, okay, aspect of our equipment. It's so easy to gloss right over it here in the software because it just does it automatically. All right, let's head over to this tab for package ASHAP. Okay, that's package air source heat pump. I'm going to deselect this button for heating equals cooling, okay, because not necessarily is the CFM the same for heating and for cooling. Now, we need to provide a number for static pressure. I think for this case, the ducts are not long, the rooms are not so big, the house overall is small. I think 0.75 should be fine. And if not, we will find out. It'll tell us. Okay, we're going to head over here, and we are going to select the equipment. Now, any of these that you see are compatible and compliant to Manual S. Manual S, again, let me bring that up.